In this video, we're going to get started with Numpy. Now, Numpy is a Python package, and for our purposes, we're going to use it to represent multidimensional data structures. It's basically, I like to refer to it sometimes as the assembly language of the PyData stack, because it's really the lowest level data structures you're going to work with. So first of all, we need to import the Numpy module. And the way that we generally do this is by convention, we will say import numpy as np. So we're going to use the alias np. I often say that data scientists are lazy and don't like to type. But however, import numpy as np, and then we will hit shift enter. That will execute the cell and insert, not insert, but create a new one below it, since it already is the last cell. So now what we can do is we can create what is called a numpy nd array. And the nd stands for n-dimensional. In other words, these are aware of their own multidimensionality. And it's basically a Python list with superpowers. And we'll see what some of those superpowers are as we go on through here. But let's go ahead and let's just create a numpy nd array. And I may sometimes say numpy nd array. I may say numpy array. They're basically interchangeable for tonight. So I'll store this in a variable named v, and I'll say np.arange9. Now, arange is very similar to the built-in Python range function. And if you pass it a number, it will return, whereas the range function would return a list from 0 up to that number, not including. The arange function will do the same, except it will do it as a numpy nd array. Now, here's a kind of a cool trick, is that Jupyter Notebook, it will always return the results of the last line of the cell. So if I just type v, in this case, it's going to show me the value stored in v. So if I hit shift enter, you can see that this, again, it looks a lot like a Python list, except it's surrounded by array, which tells us that it is indeed, we can verify this with the type function, a numpy nd array. Now, like I said, a numpy nd array is a lot like a list with superpowers, and we can even substitute the two. So for example, I could use the built-in len function, and I could see how many items are in this nd array. I can iterate over it like I could with a list. Other things that I can do, I can index into it. And I could slice it and do all sorts of other things. Now, like I said, these nd arrays are built to be multidimensional. Now, you can represent a multidimensional data structure with a Python, using nested Python list rather, but because Python is interpreted, it can be slow, especially for larger data structures. So instead, what happens is NumPy is actually written in C, because you can access memory much faster. And then there's a Python API that's bound to the C API. So you get the best of both worlds. You get the performance of C, but you get the ease of use of Python. But let's see how we could create a very simple multidimensional nd array. So I'm going to say v underscore equals v. I'm going to say reshape. And I'm going to tell the reshape function that I want to take this existing numpy nd array, but I want to reshape it to where it has 3 rows and 3 columns. So that I can see the value of that. And you can see here, this looks like a nested list, but it has essentially 1, 2, 3 rows and 1, 2, 3 columns. So now you can see that the shape, or rather if I use the shape attribute, is again 3 by 3, and also that it has 2 dimensions. We're not going to see any data that is more than 2-dimensional in this series. However, what I'm going to do is, let me go ahead and show you one that's a little bit higher dimensional with 3 dimensions. So I'm going to say np arange 24, and then I'm going to directly call reshape on that. And I'm going to say I want 2 tables, matrices, whatever, that are 3 rows by 4 columns. Hit Shift Enter, and I'll see that here I have these 1, 2, and here's 1, 2, 3 rows and 1, 2, 3, 4 columns. Notice that if you do reshape something, the product of the size of the dimensions must equal the number of values in the array. So let's look at one more cool thing that you can do with ndarray. So let's create a new one here using the arange function. So let's say x equals np arange 10, and there's the result, is 0 through 9. An array with 0 through 9. Now try adding 1 to it. You can't do this with a list because a list doesn't know how to, the plus operator is not overloaded to work with a list and an int. But with an ndarray, what it does is it adds 1 to every value in the array. It's called broadcasting. You can go even further with this. So I'm going to create another one. And this time, I'll go ahead and multiply it by 3 immediately. And then you can see it. This basically gives us every third number. Now I'm going to do something really cool. I'm going to say y minus x. And the value now is the result of doing an element-wise subtraction between the two ndarrays. So here we have, what do we have? We have, let's see here, 0 minus 0 is 0, 3 minus 1 is 2, 6 minus 2 is 4, and so on. We're going to see this concept again. We will, so keep it in mind. But that's enough for this video and enough for NumPy. In the next one, we will look at pandas.